All right, question 4. The Kyoto Protocol was signed in 1997 and required countries to start reducing their carbon emissions. The protocol the protocol became enforceable in February of 2005. Table 8.34 contains a random sample of CO2 emissions in 2010. Compute a 99% confidence interval to estimate the mean CO2 emissions. Okay, so this time they gave us all the data. So we need to take a look at this and check our assumptions. Notice it says that it is a random sample. So remember, we have to assume that we have an independent, simple random sample. There shouldn't be any outliers. And if there are some outliers, then we got to make sure that we note that there are some and how that might affect any decisions that we make. So we can't avoid these, but we have to recognize that if we have some, they could be influencing our decision. And then we have to have the normality. Okay, but in this case, they tell us that there's a simple random sample. Well, at least they said it was random. We don't know if it's simple random, but we assume so. Independence, we just have to assume that there's more than 100 possible samples that they could have taken, or not 100, but 250 possible samples that they could have taken, because our sample size needs to be less than 10% of the population. And we can assume that that's probably true. I don't know if there's any outliers or not, so let's check the data. So if I go to a box and whisker plot from list 1 and go zoom 9, there's the distribution of the data. And clearly I've got some pretty dramatic skew. So it's probably a non-normal distribution. But there doesn't appear to be any outliers. But our sample size, so for the normality assumption, this distribution is clearly non-normal, right? If I do a histogram on it, it's got this dramatic right skew. If I do a normal probability plot, it's definitely non-linear, right? I've got this dramatic bend in it here and another bend out here. So it's definitely a skewed distribution. However, our sample size is large enough, n equals 25, so therefore the central limit theorem kicks in for us, so we don't have to really worry about the normality assumption. It can be a skewed distribution because our sample size is large enough for the central limit theorem. Okay, so I've done all of my assumptions. Now all I have to do is write down my formula. So it's going to be x bar plus or minus t star times s over square root n. And again, in this case, it's t because we don't know the population standard deviation. We're going to have to use the sample standard deviation. So we're going to go stat calc 1var stats on our list of data. And I get an x bar, I can't read that, is that 3.45? So this is 3.45 plus or minus. I'm going to look up my t value. My s is 2.97 divided by the square root of the sample size, and the sample size is 25. All right, so now I need my t-score. I'll look it up on the chart. So we're going to do, what was our confidence level? 99%. So we're going to go to the 99% confidence for 24 degrees of freedom, and that gets us to 2.797 for our t-star value. So, whoops, I've already forgotten what it was, 2.797. Now I've shown all my work, and so now I can just go stat, test, one sample t interval, and there it is, the t interval, boom. We have our data, so I can just go to the data. It's in list 1, and we wanted a 99% confidence level, right? 99%. So we calculate it, and we've got from negative 0.175 up to 2.8. That doesn't make sense. So something's gone wrong here. Stat, test, t interval. Oh, I was pulling it from list 3. Notice how I could tell that something went wrong because it was from a negative 1 to a positive 2, and this obviously has to be centered around 3. So that's a good way to check, make sure that you're doing the right lists. There we go. And now it's from 1.79 up to 5.11. That makes sense. From 1.79 up to 5.11. And so now what do we say? We're 99% confident that the true mean CO2 emissions is somewhere between 1.79 and 5.11, whatever units they're in. And that's it.